Our objective today is students will be able to solve polynomials arithmetically in order to solve for x and y intercepts, intersection points for two polynomials, equations, and to see the relationship between the graph and what we have solved for. So before we begin, I want to start with what is an x-intercept? It is when the line of a graph crosses or touches the x-axis. It is also when our y is equal to 0. Our y-intercept is when the line of the graph crosses or touches the y-axis, and this is when x is equal to 0. Intersection points are when the two lines of the graphs intersect or meet each other at a point or points. That's when y is equal to y, so two equations are set equal to each other. Alrighty, so I'm gonna go online. So right now I am on khanacademy.org. It is a free program for you to use. So we're just gonna go over how we're going to solve for a variable. So this is solve for z. So I'm going to take my negative first, and I'm going to distribute it to the 2z and minus 4. So what I'm going to end up with, if you have your papers and pencils, you should write this down. But what I am left with right now is 5 plus 4z is equal to negative 2 plus 4. So how I solve for this, I want all of the variables on one side and then all of the numbers on the other side. So if I have a negative 2z here, I want to make it a positive because it's just easier to look at. So I'm going to add 2 on both sides to cancel out my negative, and I'll get a 6z on the left side and the 5, and then the positive 4. So I'm also going to subtract the 5 over here with my positive 4, and I'll get a negative 1. So if I have a 6 on the left side, 6z is equal to negative 1. My z, I have to divide by 4 in order to get it alone to both sides, will be z is equal to negative 1/6. Let's see if that is correct. And that is correct. Awesome. And I can also check the answer on Wolfram Alpha. I can say solve for z when, what was the problem? Could I go back? No. So let's do this one then. I'm going to go back to Wolfram Alpha and solve for a. And I have to do 2 minus 5a parentheses minus 5a plus 1. Equal to negative 5. Negative 5 times minus 10 plus 8a. And Wolfram Alpha will show us what to do. Alrighty. going to be 8/5. And I can see on my graph that this line here and this line here are the representations of my two equations, and they meet at this point here, which is 8/5, which is 1.66. That's equivalent to that. So we're going to put that in here. So what I want you to do, if after you watch this video, is go on Khan Academy and start practicing the multi-step equations with distributions for Algebra 1. I definitely know that you know this because we learned it in pre-algebra, but initially, since you're solving for A, you're solving for Z, you find intersections. So in this one, it's an intersection for two equations, two lines. But what I also want you to do is so for this one, I am solving quadratics by taking the square root, but here I have a 0 for my y, so it just means that when I solve for x, I will find my x-intercepts when y is 0. So if I square root these two, or the whole thing, square root of 0 is 0. The square root of x minus 10 squared is x minus 10 minus my 8. So if it's minus 8 here, or I have to add it to both sides, so it'll be 8 equals to x minus 10. 10 plus 8 is 18, so it's x is equal to 18. But I don't know why this is not like that. 64. So I'm going to copy this. I'm going to paste it on Wolfram Alpha. Oh, no, that's not it. It's this. Okay, so there are 2 points. X minus 18 times x minus 2. Oh, no. It's over here. The solutions are x is equal to 2, or x is equal to 18. I guess it's because it's a parabola. Over 2. Add 64 to both sides so we can start isolating x on the left. Take the square root of both sides to get rid of the exponent, which is the 2 here. Be sure to consider both positive and negative 8, since squaring either one results in 64. So it has to, okay. Add 10 to both sides to isolate x on the left. Add and subtract 8 to find the two possible solutions. X is equal to 18 or x is equal to 2. So for this one, determine where f of x intersects the x-axis. This is awesome because is what we were just talking about. So I'm gonna show you the hints. So the function intersects the x-axis where f of x, which is equivalent to y, is equal to 0. So we're going to solve for this equation, x plus 9 squared minus 36 equals 0. So I'd like you to pause me and try to do this problem. You can rewind me and look at the steps that were taken before, or you can just pause and do this on your own. But I do like to have you do this alone. But you can check it afterwards. So I'm hoping you paused me. So we're going to add 36 to both sides, so we can start isolating x on the left, and then we square root both sides, and we're going to be left with, because the exponent and the square root cancel out, we're going to be left with x plus 9 is equal to plus or minus 6, and then we have to move 9 over to the other side, which is negative 9 plus or minus 6 equals x. So that'll give us a negative 3 and negative 15. And that is correct. So our last hint is exactly that. Alrighty. We're going to go to the next question. So it's the same thing for this. I'm going to try to see if I can find a y for us, and if not, we can see if we can find something else. Don't need functions. So I don't see a y equation for us, so I'm just going to plug something in on Wolfram Alpha, and I'm going to show you graphs. Y. I'm going to say when y is equal to, let's say, intercept. When y is equal to x3, 3x, 3x plus 8. Okie dokie. So this is the line of y equals 3x plus 8, and it says I told it to solve for y intercept, and it plugged in a 0 for our x here, and we get an 8, and this is where the line here intercepts this x-axis, which is amazing. We can also let's do an x squared, like a parabola problem. Let's do, if I can find my x again. Oh, x to the 4th power plus x to the